Hello, Unity community, and welcome back to another official Unity live stream here on Twitch TV/Unity, and of course on the official Unity YouTube page. My name is Joy, and I'm so excited and a little bit nervous to be here with you guys today, hanging out. But I know you guys will be kind as my first hosting adventure begins. We're going to have a ton of fun exploring an awesome new course we have in the land of Unity Learn. So it's going to be really awesome. As always, it's our goal here on our live streams to bring you something really interesting or something cool to inspire you. And of course, connect with our amazing community. You guys are what makes Unity special. And I'm so happy to be hanging out with you guys today. So if you've caught some of our other live streams, you know that I'm a bit of a voxel fan, but today we're going to be exploring something a little bit different, something a little flatter, something pixel shaped perhaps. And what I personally consider magic, the art of lighting them. This is something that has always mystified me and I've always been really impressed with. So hopefully you guys will be excited too. So before we get started on that though, we do have a little bit of housekeeping to get through. So let's just jump right into that. First and foremost, as many of you might have noticed, I'm not Jackson, despite my best efforts. I can't get the beard thing right. I've tried, it doesn't work out. But one way or another, if you saw the last live stream, you know that Jackson is off to a new adventure, but he did an incredible job of just setting us up so we can keep doing what we've been doing on these live streams and bringing a lot of entertaining and interesting things to you all, because he really loved the community and he cared about everything, continuing on as normal going forward. And yeah, we're going to do that thanks to all of his hard work. So you're going to see a lot of the usual suspects on these streams. So keep on showing up every Thursday and we will keep doing all this fun stuff. Just as a heads up, Jackson still does his own streams on Twitch 2 to 3 days a week. So if you don't want to forget what his face looks like, you could always pop over to twitch.tv/FlannelJax and watch whatever game he's playing. I think he's doing Silent Hill, which is one of my favorite games. So yeah, we wish Jackson all the best and we already miss him horribly. So yeah. Now, before we get all mushy, there's one last thing that I want to talk about before we jump into the stream. And that is, of course, that Unite is getting ever closer. So at Unite 2025, reconnect with the Unity community as we return to Spain for 2 full amazing days of learning, networking, memorable experiences, and more. We'll be showcasing inspiring stories, demos, session, our annual keynote, after hours events, and a whole lot more interesting things as we go. So for more information, visit unity.com/unite or scan that QR code on the screen. So unfortunately, I'm not going to be able to go this year. So any of you who are planning to check it out, please have extra fun for me. And yeah, I hope that the experience is really amazing for you all. But for those of you who are staying homebound like me, worry not. We're going to have a ton of content. We'll be live streaming stuff. So just keep your eyes peeled right here in November. So I see a lot of people in the chat really excited already. We have the Bull over on YouTube, Mr. Awesome over on Twitch. I see we have Andrew the Day. Hello, everybody. Welcome, welcome. We are so stoked to have you here. So, I mean, all of that stuff out of the way, let's go ahead and let's dive into the stream. Let's do a high dive triple backflip.
Good, and you?
Yeah, it's a bright new day. It's my first hosting, but super excited. I think we're gonna do great. I, of course, with you guys at my side, I think everything is gonna go awesome. It's really fun to start off a live stream by covering Learn content, of course. The old bread and butter. For those who don't know, I started in the Learn side of things as well. So I'm always excited to see what new Learn content is coming about.
Indeed, yes. I do have some holes in my 2D knowledge, so I'm excited to learn some good pixel goodness.
You will.
Yeah, and that's what's really exciting about today is that, as I mentioned before, like 2D, not really my world. Like even with voxels, they're still 3D pixels, if you will. So Luna, I really hope that you're going to be able to kind of expose us to the amazing world of pixel lighting, because I don't know, Aaron, did you know that you could actually light pixels?
No, I have to say it sounds like a confusing nightmare because they're all jagged, and then lighting is usually smooth, and so it sounds confusing.
Yeah, precisely. I think you will learn a lot today, so I'm sure it will be really, really like fulfilling at the end. And yeah, as you mentioned, I think we have the idea that 3D game development might always be harder than 2D, and actually sometimes we can see that replicating those like physical phenomenons that happen in real life, that of course is in 3D, like capturing that in 2D can be really challenging and requires a lot of creativity, sorry, and technical aspects. So yeah, we're going to cover different techniques of how to light up a scene, and I hope that at the end you can look at your favorite like modern pixel art games and see how the things that we learned today are applied to those games, and then you can also apply it to your own. So yeah, I'm very excited. I think you will like it a lot. Just a shout out, this course was originally created by Unity Korea. They are really great at 2D game development. So we just took that course and like enhance it to make it more like globally appealing, I guess. And yeah, we're really proud of the final result and to share it with you guys today. So yeah, do you have any questions?
Yeah, over in the YouTube chat, Zod says it's a nightmare. I'm trying really hard to pixelize my lights. So, hopefully this is something that will inspire you to get those lights more pixelized.
Yeah, and you're going to see that actually you don't necessarily need to pixelate your lights. Like you can find a mixture of like normal lights and pixel and like shaders to create like a good effect. Like the idea is just to like use the tools that you have in Unity to create something that mimics light and like pixel light in particular. So yeah, are you guys ready?
Yeah. So let's start at the end. Let's take a look at what we're going to be
Sure.
creating.
Sure. So here I have my new Unity project. Just to let you know, when you go to like our Learn course, you will get the asset store link. So this is a full project. So when you download it, it will rewrite your current project. So please be careful, because if you download our package to an already made project, you will mess everything up. So please be careful.
Yeah, you don't want to lose that.
Yeah, please, it's really important. So here we have two scenes. Complete one. My mouse just died. Sorry, wait. Okay, so this is what we are going to be like getting at the end of the entire course, and this is how it looks at the beginning. So as we know, lighting is not only for like a visual purpose, but like to enhance the atmosphere and like tell a story. So I don't know, when I look at this scene, it just feels more like, I don't know, like a dungeon, like it like under the floor. What's the word? Like
Very secretive, very mystical. Yeah.
Exactly. So yeah, lighting it's really, really interesting to get to understand. So this is what we're going to get at the end. We have three objects. We have our witch. Again, all of these assets.
Ooh, do that again. That was really cool. Look at that. So yeah, you could really see like the shadows moving. That's awesome.
Like, let me actually move it closer. You can, yeah. So we are going to learn, apart from lighting, shadows, because of course lighting comes with shadows in real life. So even though this looks kind of basic, there are like a bunch of different light types here. There's like global lighting, there's like spot lighting, there's also shaders, there's like secondary textures. There's a lot of things that actually make the scene so like complex. So we're going to cover all of that today. Hopefully we're going to finish the entire course, but I'm not sure.
Yeah, and that's actually a really great call out. Of course, we are talking about a complete Unity Learn course. This is not something that just comes together with a button click. There's obviously a lot of work that goes into this. So this stream is really more of like a taster of what you could do to get you excited about the course. We may get through all of it, we may not, but we'll certainly get a good head start in it, so you can really get the sense of what that course is like. And if you're interested, you'll be able to go and check it out. I will drop the link to this course in the chat. But yeah, so we'll get as far as we can. We'll take plenty of time to answer questions in chat. Over on Twitch, by the way, JPN Slay PN says that this scene looks cozy. And you know what? I think I agree. It does look pretty cozy.
Yeah, the bull also said it's amazing to me what lighting does to a scene, and I was thinking, I mean,
Yeah.
the before and the before and after is kind of crazy.
Yeah, I mean, that actually, when you look at it that way, yeah, there's so much color that's coming into the scene where obviously pixels looks really flat right here, and then once you look at the fully lit scene, it's a completely different world, and that's just so cool that lighting's doing that alone.
Exactly. It's truly amazing. So again, I'm very excited because I learned a lot while doing this, and I'm sure you will too. So actually, just by doing this, we completed the first tutorial of the course that I was just looking at the complete project. So we can jump up into the next step.
Yes, all right. That's global lighting, right?
Exactly.
All right, so let's jump in and do some global lighting.
Yeah, I mean, global lighting just. I'm sure that there are some people here that are just starting into Unity, and global lighting basically like mimics the sun. So it adds light equitatively. How do I say that word?
Infinitely, like it just keeps going at the same
Yeah,
rate.
and like in the same intensity everywhere.
Mhm.
So you don't have to worry about like how it affects every single object. It just like lights up everything in general. So to add that, you just have to add a new light and global light 3D. Please be careful of not using the global light 3D because they are different components. And here we just want to use.
Would it even let you do it, or add a regular like directional light? What would happen?
I think in this case, wait,
If you add a directional light at the top of the menu there?
Allow
you? Oh, it does.
Different. Yeah, but it doesn't work the same. I think because we are in 2D mode, it won't actually work as expected.
Yeah, I mean, of course, Unity lets you do practically anything, but whether or not, what you add is actually going to work for the rest of your scene that's completely on you.
Exactly. So global light, okay, so actually the global light 2D is just a type of light 2D. So light 2D is a component that we have right here, and it can be sent to global, spots, sprites, freeform. We're going to cover these two in the next tutorials. So again, right now we're going to stay with global because it's like the most basic one. So the first thing you're going to change is the color. So as you can see, just by changing that, we can give a completely different vibe, like the water, or like, I don't know, what else?
Yeah, I mean, when you did red, of course, we all know that red means scary. So by adding in that red light, you've instantly made this a horror game. So
yeah, very creepy, like scary witch.
Yeah. Luna, I had a question. When you do a directional 3D light, the only thing that matters is the rotation of it. The position doesn't matter.
Yeah.
Does the rotation of this affect anything? If you
It doesn't. No, really, because like we're thinking like this is the scene and the light is coming from here, and you can like rotate it here, so it actually doesn't change anything at all. So yeah, it's easier to manage in this case in particular. So first we're going to change the color. Again, you can change it however you want it and do your own stuff. But maybe we can do it like just a tiny bluish, greenish color, just to add like a little bit of like theme to the entire scene. That is the first property that we have on the light 2D component. The second one that we have is the intensity. So basically just intensity. So we are like turning everything off.
It's just, it truly is turning into a horror game now. You could just
that's what I was thinking. It reminds me of like that VR horror game when you're in the dark looking for ghosts. I forget what it's called.
Phasmophobia?
Yeah, I don't know. That's it just brought me back to the horror of that.
So 2D, just 2D.
Exactly. Yeah.
Okay, just give me 1 second that I got lost. 1 second. Yeah.
over in
Okay.
chat, JPN, adjust your brightness settings until the logo is barely visible. Yes, very much.
Yeah,
That is
exactly.
the energy that this is giving right now.
Yeah.
I don't know, like you can, like in the instructions originally, you just have like completely freedom of the intensity and color that we want. I was thinking maybe something like, I don't know, like this. This is going
Just
to
a little
change.
dark.
Basically.
Yeah.
Yeah. Okay, perfect. So we have added the first type of light, and it looks way like different. Of course, it's not great, but it looks different.
Yeah.
Um,
Well, I feel like when you lower
Yeah.
if you lower the overall lighting, then the additional lights will pop more, I would think.
Exactly.
Right.
But actually, it also depends on the sorting layers. That is the next topic that we are going to cover. So, sorting layers, basically, as you know, like in 2D, we want to create like layers for the environment. So in most games, like most 2D side scroller games, there's like a polarize effect, sorry. So we have different layers that create the appearance of like depth. And we are trying to, like, of course, like in 2D, depth doesn't really exist. We have to kind of emulate that feeling of depth. So sorting layers for lighting work that way, because we can actually say like, hey, this light is only going to affect the background, or is only going to affect the objects that are like in the frontless layer. So we also have to make sure that the light, that the other lights that we are adding also work on those different layers that we are setting everything up. I know it sounds kind of complex, but basically each object can have a different layer. So for example, we have the this is, wait, I'm seeing you, like the sprite that emulates the background is set as the background sorting layer. But for example, the witch is set as the default sorting layer. So they are in different layers. And just to show that effect, if we tell the light 2D that it only affects the background, you can see that the rest are left on black, because that light is only going to illuminate the objects in the background. That in this case is only the background. I'm sorry, I'm repeating background too much. But yeah, in this case, we want, we that's the ideal thing that we want, because we're going to see in the future tutorials that the witch, the mineral, and the block game objects are going to have their own lighting independently for the rest. And we just, yeah, we're just adding layers of lighting. It's just like a cake. At the end, you're going to see the result. Right now, it might look weird, but at the end, it's going to make sense, I promise.
So that's really cool. So it's really almost in a way repeating the thought process that you had about setting up your scene in the first place. So you're still thinking in those layers, and now you're applying that same mental model of the layers to your lighting for the game.
Yeah.
That's
exactly.
great. That's great. Over on Twitch, we had a question. I'm not sure if you guys know this off the top of your head, but is Light 2D new to Unity 6, or was it also available in Unity 2022?
I think it was already made for 2022. On Unity 2018, we had like a huge new set of components specifically for 2D game development and pixel art games, like the Pixel Perfect camera. So yeah, of course, it has been improved over time. But yeah, it's been a while.
Gotcha. Well, great. Well, excellent. So do we have our global lighting now all properly set up?
Not really. We are just missing one thing, and it's that like, again, this is all, like, you don't have to follow these specific steps for your own game, but we want to create two different types of global light. So one for the background, and another one, so we're going to duplicate it for the objects located in the default sorting layer. So as you can see, when I duplicated this, I got an error here saying that you cannot actually have more than one global lighting with the same sorting layer. That makes sense, because it's like having two suns. Doesn't really make sense, because it's illuminating everything in the same. So yeah. So if I just change that to the default, now you see it's illuminating the other objects. And if, for example, I change this color, you can see that only the objects in the front are now colored in this new color for the global light. And yeah, I can just ignore this error because it's fixed.
You cleared it now. Yeah.
Yeah. So again, you have completely creative freedom of the colors that you want, but I'm just going to follow the same that we had at the end of the tutorial, that are we have an intensity of 1, and we have like a brownish color, and for the one in the background, there's like a more grayish color, and the intensity is set to 0.1.
Oh,
Okay.
wow. So dark. So dark.
Yeah, it looks very dark.
We're officially in spooky season, so it's just everything is going to be spooky coded for me.
I have to say, actually, yesterday we put some tombstones in our front yard, so things are happening.
Ooh, yeah.
Now it's official.
Spookification begins.
Yeah, exactly.
Okay, perfect. I'm just going to rename this to global light. Of course, namings are important.
Yeah.
Global backlight. Okay, perfect. So how do you feel so far?
This is exciting.
It's it's a little dark for my taste,
Dark.
but
just have
I'm
to
on board.
trust.
Yeah, trust the process.
Exactly, because we're already done with the second tutorial. I think we are going to finish this stream.
Ooh,
yeah, I like it.
We won't hold you to it, but it'll be awesome if we get through it for sure.
Yeah, I'm hoping. I'm crossing my fingers. Okay, so great. We've added like the generalist type of light, that is global light. Now, as you remember, there were other types of light 2D, like the sprite and the spot. So now we're going to add a spotlight. So it's the same process. You go to light and then spotlight 2D. This is the 3D one that it is like a sphere instead of a circle. Oh my God, circle. That was hard to say. So,
ooh, all right. Oh, wow, look at that. That's so cool.
Yeah, you have gizmos on scene, so you can edit it like more intuitively. So this is like the radius of the maximum distance the light would reach, and this is like the inner radius, like the intensity. So you can define it however you want. So this will look something like this. So yeah, it's just like a little lamp.
And so it's so cool to see, basically the 2D spotlight equivalent, because I feel like for 3D, spotlight's a little bit more of a challenging light to wrap your head around, because you got to get it into a certain position before you start seeing it. But to see this so immediate, like, it's just wow, it's just really, really cool to
it's
see
always
this light
pointed in the right direction.
Yes,
you're never gonna have it just pointed off. I feel like that always happens in 3D.
Always.
Yeah.
They have minds of their own.
They have. Okay, so this is actually quite short. Basically, we are going to add 2 spotlights, one on each side, but first we're going to change their values. So we found this color to look very nice. So I'm just going to copy the hex color. We have it on the tutorials, so it's like a little orangey, and set the intensity to 1.5. and the other radios to 6.
Ooh. So are you kind of simulating like maybe like off-screen torches, kind of casting light into the scene?
Exactly. Yeah, kind of give that vibe. Yeah. I think it wasn't intentional, but it does give that vibe.
Super cool.
Ooh, and you can see the little shadow under the box moving as you.
Oh yeah, look at that.
Yeah. That's because the box has a shadow caster 2D component that we're going to look in the next tutorials as well. So yeah, it looks very nice, right? Also the witch has one. You can see.
It's just so interesting how immediately that brings such intense depth to the scene.
Right? So we are going to add one on each side of the screen. So it looks like this so far. And now, okay.
It's interesting in 3D, you have a point light and a spotlight, but in 2D, this one spotlight kind of can do both. Because if you mess with the inner and outer spot angle, that's what turns it into more of like a cone, right?
Yeah, right.
Yeah, if you can just,
like,
I think so. Yeah.
Oh, yeah,
So it's
look
kind
at
of
that.
merged into one.
yeah, that's cool. I haven't thought about that. Yeah.
We've got a question from the Bull about can lighting be baked versus dynamic like in some 3D options? Do you bake lighting with 2D?
That's a hard one. I don't know if you can bake light, but it's not necessary to bake light for it to be dynamic. So that's important. We're going to see how to create dynamic lighting, but with shaders. Not shaders, sorry, what I'm saying, with normal maps.
Normal maps.
So we're going to cover normal maps in a bit.
Oh, wow. So, yeah, that's it'd be really interesting to see how that works.
I've never seen baked 2D lighting.
So if I had to think about it, given that it's just flat planes effectively, I mean sprites, there's really not a ton of overhead to save. And technically, like what you do when you're baking lights for 3D is you're saving, calculations, calculate light of all these like dynamic different shapes, which I don't think is actually really necessary in 2D. But it's something, yeah.
You don't see the option here in the light of, and all the other 3D lights, there's real-time mixed baked, but that's obviously not an option here.
Yeah, that's true. But that's a good question.
Yeah, absolutely.
But yeah, wait for a few tutorials because we're going to teach you how to do that. Because it's really cool. Like secondary textures are, I think, one of the biggest creations of humanity. I don't know how they even come up with that. I'm so sorry if my dog is like barking.
All pets want to be on stream.
Right? Okay. So we are done with the spotlight. This is moving really fast. Amazing. Now we're going to cover the third type of light 3D, which is the sprite. So again, let's add another one, and this is really cool. So we are going to add a sprite light 3D for the mineral. So again, you are like, this course is really interesting because it's showing you how there are like so many ways you can actually illuminate light. There's no like a right or wrong way or like a specific guide of when you should use a certain type of component. It's just like based on your own criteria of how it will look the best. So once you add the the sprite light 3D, you can see that it has like a literal shape.
Oh, a little shape. Yeah.
A star. So it's because that light takes the shape of the sprite you are giving it to.
It's kind of like a cookie in 3D lighting, right? You can set it as is that what it's called?
Yeah, it's a cookie.
Yeah. And it's kind of shaped the light. Yeah.
Or I was thinking like, I don't know, you have seen those like paper lamps that have like cutouts outside.
Yeah,
exactly. It's like that. So in this case, we are going to add a sprite that emulates the shape that the mineral will reproduce. So let me show you. So sprite that we have, it's this one.
Okay.
That's literally a sprite. So you are not actually like making it dynamic or like, it's not like an animation or anything. You just have like a sprite that you pass it to the light and it takes that shape and that's it.
Can I see that image again, Luna? The spotlight image? Oh, so is it like is it the more transparent or dark it is, the less light gets through? Maybe like the full white means full light.
Yeah, like the alpha value gets reduced.
Yeah. Okay.
Exactly. So yeah, now that we have that, we are just going to make sure that it's aligned. So I think the mineral is at 3.5. Yeah. So we're going to center it so it looks like it is coming from the center of the sprite. And lastly, we're going to change the color because if I see that, I think white is not the right color. The light will emit maybe like a bluish one that looks more natural.
Mhm.
What do you think?
Yeah. And I was thinking the way that the light has like harsh transitions between, brightest, less bright is kind of in the pixel art style almost, right? Like there's it's not a smooth diffusion of light. It goes,
Yeah, exactly. I think that's really interesting. You have to like it seems very simple, but actually it's really complex to kind of take everything to pixel like manually, instead of just putting it like in a software and just doing its magic, and so it gets pixelated. So yeah. Anyways, so far so good.
Yeah.
Yeah.
So the cool thing about this, it seems like, is that you can set the shape of the light to be any sprite, right? So over in the chat, Yosino asked if we could change it to be the same sprite as the mineral itself.
Yeah, I was wondering.
Wow. I think
But
so, yeah. But it will.
But it wouldn't have the alpha values,
yeah.
right? You'd need to convert it to.
Yeah, and it doesn't really give the same effect. Again, this was intentionally created to create this effect, but I don't know. It could be like more wavy, or I don't know, anything that your mind actually creates, because you have to create that manually.
So it looks like the key for the sprites here is that you do have to have that dedicated alpha channel, so you can kind of define how the light kind of expands out. All right, so like if say the creator of this asset had created the crystal light in that shape, but actually created a dedicated alpha channel, we could do that, but because it's just a plain old sprite, it's not really going to show up the same way.
Exactly. Exactly. Oh my god, I forgot to rename my stuff.
Oh,
you got to keep with the naming. We got to keep our hierarchy nice and organized. Number one rule.
Yeah.
Yeah, I was thinking when you're done renaming, Luna, I want to see a current comparison of the current scene versus the final, and see kind of like how our progress is coming along.
Sure. Let me show you. So again, this is how it looks on the basic so far.
Yeah.
And
oh wow, yeah, we still got a long way to go.
Yeah, a lot
for the magic.
But you can see, of course, I think I might have set the global light a little bit too orangey.
It's all up to your own personal design. That's the thing.
Yeah.
Exactly. It's the same. So actually, sorry, go ahead.
Oh, no. I was just going to say that, like, even thinking back to where we started, where everything was just so flat, like even flipping between the two, there's still a lot of depth that you've already created with just the lights that you've added in. So we can see how this is building up like a painting almost.
Yeah, exactly. It's really like, because at the beginning, I feel like you guys must have feel like it was quite disappointing because everything looked really dark. But yeah, it's just like layers and layers, and it just creates complexity. And again, it's based on your own criteria of how many lights to choose, because of course, like extra lighting can also be. Oh my god, I'm so sorry. So yeah, you have to find the right balance, and I think that's also in your job as a developer to find how it looks best. So I was just going to mention something, and is that if you remember when the witch, well, we have to fix two things. First is that the witch actually like is able to cover certain parts of light.
Oh,
you can see there's like a shadow here. So it blocks lighting. And the second one is that you can see the light pulsating as if it was like real. It was dynamic. So that is actually not done with animation, but with coding. But we are not going to code in this tutorial. We just have it prepared. So don't worry, because yeah, right now, if I come here, I stop the light, but the light doesn't pulsate. So yeah, that's the next step. I'm sorry. I was just going to say that I'm also quite nervous. I forgot to mention at the start.
No. You're doing fantastic. What are you
great.
talking about? You're
You're doing
great.
great.
You're great. So, does that mean that we're going to be moving on to emissions now? Is that what's up?
No, not really, not
Oh.
yet. Is that there's so many things, right?
Yeah.
Like there's many ways of actually creating that effect. So we are going to do that right now with coding, in particular with script machines, because as we didn't want this tutorial to be focused on anything else apart from lighting, we already provided script machines for you to add.
Which is just visual script functions, right? Yeah.
We're going to open it in a minute. So to add the script machine that we created, you need to add a script machine component. And once you add it, you also get a new variables component that you're going to define. So in this case, we are only going to need one variable that is going to be the speed in which the lighting states. We're going to name it speed. And it's going to be a float. And okay, actually, let me open the script first so you can see what it is. So the script machine that we created is called the scale wave. So let's see.
Look at that.
Yeah, it has a lot of.
It's been a while. Been a while since I looked at a visual script.
Really?
So, wait, what is this doing again? This is.
It's just pulsating, like changing the.
Oh, okay. I got you.
So you get like a certain amount, you multiply it by the time. So yeah, you can basically get a certain speed, and then you multiply like the size with your vector tree. Like this is very complex, but basically you're getting your original size and multiplicating it like back and forth. So it like gives the feeling that it's like pulsating.
Mm-hmm.
So that is why.
I see some trigonometry function there, which is the sine function for doing it. This action.
The wave. Yeah,
the wave.
Exactly.
Not to be confused with this wave.
Yeah, which is also good.
It's hard to do that, in a game. You just have a bunch of little characters doing that instead of lighting. Yeah, it's too complex.
Anyway, so we have created our speed variable that we're going to feed our script machine, and now we just have to set a value. So the one that we found worked best was 3, but again, you can choose it if you want it to be pulsating like really fast, as if it was like dying or something, or pretty slow, calm vibes. Once you do that, it is done. Now it works. So you go to play mode, you can see that now it is.
Oh yeah, that's really subtle. So with your variable, can you punch that up to like just really show, like make it crazy?
Yeah. I don't know, like.
Oh yeah, look at that. That's really showing there. So now it's like very actively pulsing. That's really cool.
Exactly. So yeah, you can choose whatever value you like. I personally like it to be kind of slow. I don't know, like a tiny little. So yeah, that's it. Oh my god, we have finished already tutorial 3.
Wow, yay.
Ryan.
Okay. Oops. Okay. Now we're getting into like the deep stuff. Shaders.
Ooh, now we're moving on to the emission shaders. Okay, I'm excited for this.
Yeah. So what's your experience with shaders, if I can ask?
Oh, man.
And minimal. So I won't be able to contribute too much to this.
Aaron, you're not neck deep in Shaderland. You don't, weave all the visual aspects or type all the code.
I do not. But I aspire to one day.
Yeah, actually, in reality, I haven't done a ton of shader work either. Like, I'll jump into shader graph here and there. But Luna, I think you're the expert here today.
No, I just asked the question, but that doesn't mean that I'm an expert. Definitely not. Because shaders for me are one of the most complex and interesting things in game development. I will love to be like an expert technical artist one day, but it's just so hard. But we are not going to be like getting into the deep stuff. Just like an overview of what a shader is and like the ones that we created, how they work. So yeah, shaders basically, just to give like a quick overview, are a way to create the appearance of I don't know if texture. No, it's not texture. Texture is not the right word.
Kind of like
but like
surface material.
yeah,
The
mhm,
features. Yeah.
exactly, like features of materials, like something shiny or something like with bumps, or yeah, many other things. And there are different types of shaders as well for any type of these areas. And one of them is the emission shader. So as name suggests, it's basically to create the illusion of something emitting light without actually adding a light component that of course will add like computational calculations. But it is like again like giving the appearance of something that doesn't really exist, which is really cool.
Yeah. Fooling the eye.
Yeah, that's amazing. So
Awesome.
we are not going to create our own emission shader from scratch here because that will take a lot of work and explanations. So we're going to show you the ones that are already created. So in our shaders folder, we have our sprightly emission shader. And
Oh
once
boy.
yeah. So this is how it looks, and actually, it's not that complex. I'm going to try my best to explain what it is doing. So. So as you might know, sorry, there's like two different types of shaders, like base that are like framing shaders and spot. No, I forgot the word. Wait, there's fragment shaders.
What was the first type of shaders? Fragment shaders?
Yeah, fragment and vertex shaders. Sorry.
Oh yeah. Yeah.
Yeah. So those are the two different types of shaders that again I think I'm not the best person to explain them in detail, but I guess this course again is just like a motivation for you to learn deeper into the subjects. But in this case, this is a fragment shader type of shader. And what we're doing is that we have our emission map that we are going to explain what an emission map is, and then we are multiplying it by our emission color, and we're basically adding that into our original like mask of our sprite. I think that was not the best explanation possible, so I'm going to demonstrate what I mean by that.
Yeah.
I'm trying to see what these little things are on the left. This column of them. I can't quite read them. Yeah, main texture. And it's
mask texture.
sample. Oh, mask texture.
Yeah, the normal map, the mission color.
And these are effectively all of the variables that you've created for this particular shader graph.
Yeah. Yeah, exactly. So these are the variables. And just side note, I'm going to explain again what mask texture is, sorry. But you have to be really careful with the namings you have here because they have to be the same as the one you mentioned on the sprite editor. So now I'm going to take you there because that looks very confusing. Okay. So emission maps are a specific type of secondary texture. We have a dedicated YouTube video only talking about secondary texture, so you can find that in our YouTube channel.
Would highly recommend that. I watched that and it kind of blew my mind.
It's really good. That video is really, really good. But basically, secondary texture is like more data that you can add to a sprite to give more information about its surfaces. So let me go to our witch sprite and show you what I mean. So for people with knowledge of 2D development, you know that usually you have to create a sprite sheet for the animation of your character. So you don't animate characters as in 3D with like skeleton and all of that, but you create this is the traditional way things were animated back then, right? And
Little keyframes.
exactly. So in this case, we have our completing with our witch. And as you can see, it's just like the plain colors and like texture of the witch. I don't know how to explain it more specifically. I think it's just something that you really have to do to get the sense of what it is doing. But they are like the secondary textures are things that define how each part can behave with lighting, with I don't know, with shadows as well, with emission. So in this case, as you remember, the sprite needed a mask texture and an map and an emission map. So we have that. We have our emission map that, as you can see, is kind of the same, but it just highlights the areas in which light will be emitted. So
It's just like the sprite earlier from the circle where the white part is the part that emits light and the dark parts do not, right?
Yeah, kind of.
Yeah.
Right.
You have to be
And
coloring.
yeah. No, it looks like we have is it the witch's wand that's going to be lit up here? Is that what's masked off here?
Exactly. You see that it has like a little rock. So in theory, you want that rock to shine. So that's the reason why that area is only highlighted in white. But again, in your own project, you want to leave white anything that will emit light, and the rest in black. There's no like middle ground. There's just like white or black.
Yeah. Okay. So lit or unlit. Yeah. Great.
Exactly. And this is the mask. Let me show the mask is used here. Yeah, we will use our mask. So sorry.
I
Okay.
learned something about the normal texture too, just recently. Which was, can you select the normal texture? Joy, you probably knew this, and Luna, you probably did too, but it was new to me that I always wondered why these are purple, and it just seemed kind of random. But that they are mapped, the colors are mapped to the direction of the like Unity axes, where if it's pointed to the right, if it's red, it means that surface is pointed to the right, just like in the Unity scene.
Yeah.
And green, for up. Anyway, blue for whatever. And so it ends up being purple because that's sort of neutral, right?
Yep.
Yeah, there's actually like a lot of calculations. Again, in that video that we mentioned, there's like a lot of like a better explanation. But we're going to look at normal maps in the next tutorial because it's an entire
no spoilers, Aaron.
Yeah, no, but it was a good shout out. But yeah, sorry, I accidentally opened not the wrong one, but the emission shader that we created is not for the witch right now. It's for the mineral. So if you come here and look at the mineral, it also has an emission map. So again, only like the border, it's highlighted in white because that's the area that is going to emit light. The rest is going to stay the same. So to make everything work together, what we are going to do is
do we need to apply the shader?
We have to do something first. That's what I'm finding.
No worries at all. We're doing it live, and that's just fine.
Yeah, that's fun. Great.
All right. Well,
I've always wondered how people actually make these textures. Like, I'm sure there's programs that make it easier, but in my mind, I would just be like duplicating the witch sprite sheet and then like filling in all black and then just like coloring it. But there's got to be tools.
Yeah, there are a lot of tools out there, and there are plenty of people who actually just build sprite sheets like this in Photoshop, but there are also dedicated
Mm.
tools that are more oriented towards pixel art. But yeah, back in the day, all you needed was MS Paint and a lot of patience, and you could do anything through MS Paint.
I think currently, like the biggest software used for this is Sprite. I think it's called. Sprite.
Oh yeah. Mm-hmm.
Actually, these were created with Sprite. Just to let you guys
Oh,
know.
great shout out. That's really
Yeah,
cool.
it's really great. Okay, I found it.
Oh, great.
So, yeah, the first thing that we have to do is actually add the correct material to the mineral and the witch as well, because yeah, we have to light this thing up. So we have created two materials for the mineral and the witch that you can find in the materials folder, and you just need to apply them to each of the objects. So this is added to the mineral and this is added to the witch. So as you can see, this is very subtle, but the rock now looks pink. And if you saw, this light now looks a little bit like greenish. And that is because our emission color is set that way. So
Can you just Command Z a couple of times and then go then redo so we can just see the, okay.
So
yeah.
that was,
oh yeah, oh, very subtle.
Yeah, but you're going to see how this actually, like this is just the first step. We're going to make everything work. So mineral and witch. Oh, okay. So why was this step necessary? Because in our emission shader, we see that we need an emission color property. And that emission color is this one. Like it's talking about this property right here. So again, this color is going to get multiplied by our emission map. So basically that means that light is going to be applied, that color is only going to be applied in the white areas of this map. So that is the reason why it looks pink here and blue here. Okay.
And so many things interacting.
Yeah, exactly. It's just very complex. These next tutorials are the hardest one, so it's taking me a little.
This is amazing. You're making magic happen right before our eyes.
Right, that's true. So again, used to show you how these maps were added to the mineral and the witch. You can go to the sprite editor. That basically is the window that edits everything of the sprite itself, like the slices and like the size itself. I'm going to open it. Here you have the sprite editor. And there's a part here called secondary textures. And here's where you add all of your secondary textures again. So in this case, we just have one, that is the emission map for the mineral. And for the witch, we have the normal map and the emission map. Normal map, again, is for the next tutorial, so don't worry about that right now. But basically, yes, everything is set that way. This is the reason why the shader will now be able to take the emission color, the emission map, and multiply all of that to create the actual appearance of light. Because currently it just looks pink. It doesn't look really like light. So we are just going to add that magic in the next step. So to do that, there's something wrong here. I just realized.
Well, that's okay. Walk us through what we are looking at right now, what you think might have happened.
The reason is that I cannot find where we added the shader.
Well, the shader was attached to the material, right? I mean, it was, you can see in the top right.
Yeah. Sorry. Yeah, but I realized that in the tutorial, I forgot to mention that. Yeah. Anyways, okay, great. Thank you, Aaron. Okay. So actually, that part is done. We're going to polish that light in the next step. where we already done with the Emission shaders.
Ooh,
We
amazing.
yeah, great. It was, in theory, each step is quite simple. You just need like a lot of background in theory to understand. So I'm sure that when you guys actually follow the tutorial and get more time to actually understand each step like in detail, you will feel way more comfortable.
Well, this one's crazy because it's the shader interacting with the secondary textures, interacting with some other stuff. It's just a lot. It's a lot going on.
Yeah, we've really started building up this complex woven setup within Unity, and it's really incredible to think that this is still for just a 2D game. So there's so much going on in the background to really differentiate this from just some pixels on a screen. So there's definitely a lot of complexity here.
A lot. And like, again, I want you guys to please look at your favorite game right now, like pixel style, and you can see like each part that you didn't consider were light, or you didn't actually like take the time to realize that about lighting, and see how complex everything is and how lighting actually is very important for the game that you are playing. So yeah. Anyways, now we have shadows.
All right, moving on to casting some shadows. Amazing.
Yeah, this
don't we already? I feel like we already have some good shadows going on.
Yeah, kind of automatically. Yeah.
We're just going to explain how it works and actually talk about the computational calculations of shadows, because shadows are really consuming for your computer to handle.
Yeah, or like expensive.
It's kind of universally true, 2D or 3D. So
I remember when the first time I heard the term expensive, and obviously being confused about thinking that it was monetary value and not
resources. Okay. So if you guys are familiar, now we're not going to look at the actual scene, but at the renderer 2D file in your project. So when you create a new project, you get a renderer 2D asset. So basically, this is your renderer file that handles all of the render like calculations and how, like, for each type of project you get a different one. So for 3D you will have a different type of renderer, and for mobile, etc. This is just like more deep stuff that we are not going to cover because it's just quite like difficult to get. But just to say that by default, when you create a new project in Unity, your renderer 2D file will have the max render texture. Okay, the render scale, set to 0.5. So let me show you how that changes your project. So if I set it to something like here, so I don't know if you can see it, but it looks very like
if you drop it down to like 0.2, it might be easier to see, just to see that more extreme.
Maybe. Actually, let me first search the correct one. Yeah, it's this one.
Yeah, drop it way down.
Yeah. Just make it easier to see on the stream too.
So I don't know if you can see it. Yeah, it's very subtle, but it looks a little blurry. Like the edges look kind of blurry. You can.
Yeah.
Can you see that?
Yeah, that's definitely coming through. Yeah.
Yeah. So that's not what we want, because in Pixel we want everything to be sharp, right? The edges to be very defined. So the easiest way to just fix that is by setting the render scale to 1, the highest value. So now this is how it is for the project.
Oh, it's super sharp now. Yeah.
So that was just a really small change, but that helps a lot, not only with the lights, but with the shadows as well, to define how shadows are delimited. And also, this doesn't really increase the computational calculations as much. So it's really subtle, but it gives a really good effect and it's not really expensive. So it's just a win for win. You can try, use different values and look at the frame debugger to see how expensive that is, and you will see very small differences between the two of them. So again, the render 2D file is related to everything about like the shadows and lighting and how they are rendered and how expensive that can be. So you can edit these to find in your own project the best values that give the best results and doesn't crash your project. And lastly, related with shadows, you can see that, for example, the block has a Shadowcaster 2D component. So the Shadowcaster is in charge of casting the shadows. When I disable this, you can see that there's no longer shadows.
That's that really magical component there that's really picking up on all the lights. Okay.
It's very magical, simple, but it actually does a lot of calculations in the backend.
Yeah, we actually had a question in the chat that might be relevant to this component. Over on YouTube, Nicholas Moreno asks, can you limit how far shadows are cast?
You can, like, you mean, for example, like, I think with the trim edge, you can define.
Oh, yep, that's exactly it. Like how long those shadows are. So, okay, so you can, and it's right there.
Yeah.
Although I think that's more like side to side. I think Nicholas might be asking, in 3D, there's like a max shadow distance, maybe, or oh, I'm not sure actually. So I didn't see that in the 2D renderer asset.
Yeah, no.
Oh, okay, so maybe then in 2D this isn't the case.
Render textures. I think we have to look into it because I don't have the right solution right there. Honestly, I'm not really that proficient with like the render files, so sorry.
Yeah, no worries at all. No.
Okay, well,
I'm Googling it.
Okay, thank you.
All right, so we've got our shadows going. You showed us that 2D shadow component, so that's great.
Yeah, and we're going to add another one to another object right here that is our mineral. So as you can see, this is like supposed to be like a platform. It actually has, if I go to my mineral, it has a box collider here that is where the witch can jump. So if you think like in real life, when there's like a platform and light is coming from on top, the light gets blocked right underneath. So we want to give that appearance. And how we do that? With a Shadowcaster component. So if I add one, oh, sorry, we have already added one. We just need to activate it. So that's why, because you cannot add two Shadowcaster components to the same game object, only one.
Gotcha.
So once that's added, you can see that it looks like a square.
Oh, it's very boxy.
Yeah. And it's because it is using the casting source as a sprite renderer. And that sprite is taking the shape of the mineral sprite. That it's like this shape, like square. So that is why it looks square. We don't want that. So to fix that, we are going to change the casting source to box collider 2D. And you're going to see the magic when that happens. When I do that.
Oh, look at that. Okay, so it's picking up because you've got that little narrow one. And so that's awesome.
Exactly. So it's very cool because, again, I think you didn't consider a collider to be a way of casting light. So that's really interesting. And yeah, again, there are other properties that you can play with. But for the purpose of this tutorial, we just wanted to add that little part. And as you can see, the witch also can like interact with the shadows created by that collider.
Oh, that's so cool.
Yeah, it looks really nice.
Yeah, it's amazing to think how once again, we're taking components and really making them multi-purpose. So obviously we originally put that collider there so the witch could actually jump on top, but now we're also using that collider to define where the shadow should start. And it really does kind of reflect real life, right? Because if there's this, as you wander through dungeons in your day-to-day, as we all normally do, when you're jumping on these crystal plinths, the lighting is being blocked by that plinth. So it makes total good sense to me.
Yeah, for me too. Yeah, as you said, like I do that every day. Okay, so yeah, I think we're almost done, so I'm very excited. I feel a little nervous these last tutorials, but
no. So we're actually sitting at about 25 minutes left. So give time. Do you want to try for one of the pieces that you're particularly excited about? We've had some conversations about the normal maps. Would you want to explore that, or?
Yeah, actually, normal maps are the next tutorial.
Yeah, and someone did mention that they wanted to see post-processing as well.
Sure. Actually, those are the two ones that we have left, and I think we can do it. We can do it. Okay, so actually, normal maps are also kind of hard to understand. As Aaron mentioned, let me show you. This is a normal map. Okay, this is really small. Normal maps are usually kind of like these bluish, purplish sprites. And you might get the feeling that those colors are really random, but actually they are based on a sphere. So imagine we have a sphere and we just made it 2D. So we squeeze it. But to define that depth, we add color for the vector length. So each color of this not only means the length, but also the direction that the original sphere surface was facing. That makes sense? Yeah. So you squish that and make a color scheme for depth. That is normal map. And pink is always on the down left side, and this green always on the left. Sorry, yeah, left top, and this was the right bottom. Because we want to tell the computer that light will reflect as the surface of the sphere in that specific area. That makes sense with that? Yeah.
Yep.
Again, it's really complex, and you might need more information to truly understand it, but I'm trying my best to explain.
I'll put the link to that YouTube video in the YouTube chat anyway, or I'll maybe Joy, you can put it in both. I'm not sure.
Okay, thank you.
Yeah.
I did study before this, just to let you guys know. But it's so hard with all this pressure.
No. I mean, remember, you're doing an entire course in one 90-minute live stream.
Yeah.
When we're putting stuff on Learn, we're like, okay, yeah, let's give them a couple days to get through this, and you're like, no, fast, quickly.
Yeah, that's true. That's a speed run. But I hope that you guys are I don't know, just actually grabbing the important stuff of this course and just motivating you to actually follow the course and learn. Okay, so normal maps. Normal maps are really cool. And we are just going to look at the normal map of the witch and the block, because the mineral doesn't have a normal map. Not because it doesn't have to, but just because, I don't know, it was just decided it didn't need in this case. So let me show you again the normal map side by side. Okay, so again, as you can see, the purple is basically this purplish means neutral. So light doesn't really reflect in any way, it's just plain. But this is showing you that light has to reflect particularly as this color in the original normal map wheel should I know that's really complex to get, but let me show you. Let me show you.
But I feel like you can kind of see it sort of looks like a 3D shape when you
Yeah.
look at that normal map.
Yeah,
It's definitely lifting off. It's not just the
Yeah.
flat.
exactly. Basically, you just want to create the appearance of depth, and of course, light reflects differently on different depths in real life. So that's what we want to do with normal maps. Okay, so let me move my witch close to the mineral, and as you can see, like it affects the witch the same in every part of the witch. Like lights get affected the same, right?
Mhm.
You can see that.
Yeah, it's a straight transition, really. It's just shadow, light.
Mm-hmm. And the same with the block. Let me move the block. Okay, actually, this is easier.
There you go.
Yeah, if you can see, like it was the same.
Yeah, just so it's just flat across. It's either it's lit or it's just
But it's
right there in
lit.
shadow, and that's it. Yeah.
Exactly. So we can change that again with our normal. So to do that, let me take our mineral light and change the the shadows. Oh no. In the volumetric section. In neither of those ones, in the normal map section.
That makes more sense. Yeah.
That makes more sense. Yeah, you can see I'm nervous right now.
No, you're doing great.
Okay, so it's set to disable. That means that light is not affecting normal maps because it's disabled. So we can just change that by setting the mode to accurate. Fast and accurate are, again, it's just like enabling, but there are different calculations. So you can see which is more computationally expensive for your own project. In this case, accurate works well. So when doing that, you can already first see a change in the emission
Yeah.
shader of the mirror.
Yeah.
But also now, again, as the witch has normal maps applied to it, if I come closer, it's very, very subtle. Yeah, but you can see like the border now lights differently.
Oh yeah, on the
Yeah.
hat anyway.
Yeah.
Yeah, I think the
Yeah,
hat's the
that.
perfect place to be looking when you see this.
Exactly.
Yeah.
It's very, very subtle, but it makes a change. And again, you can like play with values to make that effect more visible if you wanted to. But that's basically what normal maps are for, to define where light will reflect and in which has intensity based on its depth.
Mhm.
Okay, perfect. So now we're going to add a different and the last type of lighting that we are going to add in this project that is called rim light. So rim light is not necessary. It's not a component, like a built-in component in Unity. But if I don't know if you think of like a museum that has like light behind like an art piece to give like the appearance of depth and like to showcase it. That's basically a rim light. It's just a type of light to enhance the appearance of something.
It's like it's coming from behind it.
Yeah, coming from behind it.
Right.
So we're going to add rim lights for the spotlight study that we have created previously, as well as the mineral one. So again, it's not really a built-in component. It's just like mimicking that effect. So if you search rim light, you will understand what I'm trying to explain. So for doing that, we're going to just duplicate all of these. And we're going to change the intensity value to a higher value because again, it's just like a spotlight for like narrower and just wanting to like showcase the object, like to give depth to the object by adding light behind it. So we're going to set the intensity maybe to something like 10.
Yeah.
Yeah.
My eyes. It's like those the light blast things. You know,
Yeah.
it goes like
Yeah,
grenades.
yeah.
I don't know.
We're going to change the spotlight outer values to 4.7 approximately, and for the mineral to no,
Right.
no. And we're going to change the property. Oh no, we already changed the intensity property. Now we just have to change the normal map quality as well to accurate, as we said previously. So again, it will affect like normal maps, and set distance to 1. So again, it's like that changes like how far it will affect the, or will take into account the normal maps of objects. Sorry.
The bull
Still seems
chimed
too
in.
bright.
Yeah, the
Yeah.
bull says it actually looks pretty cool, and I agree. I
Okay,
think this is pretty neat looking.
I forgot. Like I duplicated the mineral light, but because it's kind of a spotlight, we just have to change this to spot.
Okay, there we go.
That's really glowing now.
Ooh, looks enticing.
Looks so good.
I feel like, Indiana Jones. I want to go up there and swap it with a bag of sand.
Yeah.
See, my first thought is, it looks like, a gummy or a jelly thing, and it's like I want to eat it. Forbidden cake jelly.
I can tell, Joy. I think. Have you eaten breakfast yet?
No.
When you start talking about wanting to eat minerals,
Hey, they say that minerals are good for you.
That's
and like
true,
even on those cereal commercials, what do they say? Full of vitamins and what, Aaron? And what?
You're right. You're right.
And
you gotta eat them. You need them. Yeah, it's true.
Okay, yeah. So the last thing to make this like cohesive, because it looks kind of weird. I appreciate Bull for saying it looks nice, but it could be better. Is that again, we just want these lights to affect the actual object. So I just want it to highlight me, like to be like, behind me. So for that reason, we are going to change the certain layers from everything to default. Meaning, as you can see, it's very subtle, but now that light that looked very shiny, it only affects the witch, the block, and the mineral.
Yeah.
Luna, could you just move the witch like in scene view?
In scene view?
Yeah, just to see.
So,
Yeah. Oh yeah.
Can you
There
see
you
like
go.
like these things right here? How they
it sort of reminds me of like every YouTube thumbnail with just like the white outline, like it just pops more. Yeah.
That's really cool.
Yeah, there you
What's
go.
so interesting now is that it really feels like the crystal is being lit from within, whereas before the lighting was kind of like, oh yeah, there's a light there, but now it really does feel like it's emanating the light.
Yeah, it makes it look even more delicious.
I'm not stepping down from this. I think this is a good idea. I feel like I'd get powers by eating that rock.
It's so true.
I think that's the future, actually. We might have to eat minerals in 30 years to be able to survive. Okay, yeah, and also the block. The block also has a normal map, so you can see how it lights differently. So if I put it on top, you see that this part is highlighted less compared to this part, and so on. Do you see? You see?
Woo! That's really cool. Looks great.
Yeah.
Well, I just want to. Oh yeah, go ahead, Aaron.
Yeah, I was gonna say I want to get the post-processing in here for the final.
I want to call out that we are getting close to the end. So
I know.
Is post-processing something that could be really quick, or do we want to leave it as it's really quick?
It's quick.
Yeah, it's really quick. I mean, like getting to understand post-processing is kind of hard, but I think we can just, because we have already set the post-processing profile file, so you just need to add it and that's it. So we're going to show you that very easily.
Yeah, let's just take a look at them, and then to learn more about post-processing, you could definitely check out the Learn course, which we'll be plugging here in a minute. So let's just see what the post-processing looks like.
Perfect. So again, post-processing is just like adding filters to your images. So for doing that, you're going to create a global volume game object in your scene, and you get prompted to create a new global volume, but you don't have to because you already have one that is called the sample scene profile. Again,
do you need to enable post-processing on the camera?
Yeah, exactly.
Yeah.
So again, as Aaron mentioned, even though you add the global volume, you need to go to your camera and under
rendering there. I think I see it
here.
Yeah.
Yep. Just have to click this and that's it. Or not.
Let's see. Can you go to the global volume again?
Yeah, Bloom is already activated. Let me do that really quickly.
So I see we have vignette. How's it looking in the game view? Were you able to?
Yeah. Okay. Yeah. Okay. Yeah. Actually, this is very, very subtle because we just added the bloom effect. So bloom basically is just like blurring the lines of light, like creating halo. So if I don't know if I set the intensity higher,
right? Yeah, there you go.
Yeah, there you
go.
Ooh,
look at that.
And then yeah, the it's interesting. The like vertical lines have more depth, I feel like, than I originally realized.
Yeah.
Do those have like a normal map or something? What's going on there?
No, I think it's just like that. The emission shader gets from here because it's like lighter in color. So
yeah,
more.
That's cool.
Oh, I feel like we're in a Hollywood movie now.
Yeah.
Lens flares everywhere.
Yeah, exactly.
The way that we make entertainment.
Yeah, let's just leave it like that. It's very neutral. But yeah, basically you can see how magical post-processing effects can be. Again, this is just based on your creativity. There's not right or wrong way to do this. It's just like based on your own liking. And I think we can just do the last thing needed, apart of course from like publishing your game online, and is that if you enter play mode and you move your witch close to light, okay, actually it's not necessary anymore, so just ignore me.
No, I think this looks really great. And it's amazing what you were able to throw together just within the scope of the stream. If you guys remember when we started out, the scene was very flat. It kind of had a gray tone to it. It definitely didn't have hinted at lighting. It was just blah. And we went from blah to ooh with shiny, edible, yummy rock for Joy to eat. But no, it's really interesting to see how just adding a little bit of light adds so much dynamic style to a scene like this, which is really fantastic. And I just want to say thank you so much. This is really cool. And for those of you that want to go through this course for yourself, you definitely can do that by following the link in the chat. There it is right there. We have just a couple minutes left. So to close out, Luna, Aaron, are there any tips you want to give for people who want to go through this course? Any thoughts about 2D lighting in general? Anything that you want to shout out to the group?
Well, I mean, this course is amazing and really quick and fun to get through. And there's also a really awesome 2D sample project, the Happy Harvest project, which has incredible lighting, 2D lighting. It's not pixel art, but It's got a lot of really awesome examples as well. If you want to continue learning 2D lighting. And also just want to give a shout out to Joy for doing an amazing job hosting, and also to Luna for doing an amazing job. First time leading a stream also. So good job.
Yeah.
Thank you.
Yeah. I definitely want to shout Luna out as well. You know, you said you were nervous, but you did an amazing job and you got lots of love in the chat. So really, thank you so much for guiding us through this really cool stuff. Let's see, just one quick question from the chat before we close out, from WireX on YouTube. Maybe this is more advanced, but if it's a torch and I want the character to walk around the stage with it, how would I illuminate while moving? That's like the witch's little crystal, right? So that's already set up. So
think
it's
so,
just
yeah.
with a mask,
Emission,
right?
like a mask, exactly.
Yeah.
With mask, secondary textures, you just have to get into that.
Awesome.
Yeah, I just want to say thank you very much, guys. Again, yeah, I was very nervous. It was my first time, but I really appreciate you too and everybody's patience. And yeah, Joy, you did amazing. So thank you very much for staying with us today.
Yeah, amazing. Thank you guys so much. And yeah, as we are wrapping up the stream, want to remind you, already put it on the chat, but this is a course on Learn. You can check it out today and complete it. Next week, we will have another stream, same time, same place. We are kind of finalizing the details, but I am able to tell you that Mr. Ben Cloward will be returning for another really cool visual effects stream. So he's going to be using shadergraph to give the illusion of complexity where none exists. So, ooh, that sounds really fascinating. So, tune in here, same time as this week for that stream. Reminder, we have a Discord. We have Unity discussions. Please keep the conversation going with us throughout the week. We're always here for you. And yeah, I want to thank you guys so much for coming and hanging out with us. This was my first stream and I was nervous, but you guys are so lovely. So as usual, community is the best and I felt so supported. Thank you to Luna and Aaron, and have a great rest of your day, you guys, and we will see you again soon. All right. Bye-bye.